This video is part of a playlist. If the first one you see is this one, then I highly suggest you to go watch the entire playlist system so that you do see the important informations relative to this series. So I suggest everyone to go watch the introduction, which contains information which are important for every viewer. And if you are a beginner and have actually no programming or low programming skills, I suggest you go watch the basics and terminology of gdscript. If you are starting with Godot and are making one of your first projects, if not your first project, I highly suggest you to go watch the Node and Objects video about Godot. It could be interesting if you consider yourself a beginner anyway and need some extra guidance into understanding how to work with Godot on your own and be independent. So anyway, in this video, we will be making our first scene. In this first scene, we will create a resource. We will allow the player to generate this resource. And at the moment, it will be contained within one scene. So let's actually start by creating a simple Godot project. So first, I will set it in my Godot folder, and here we will have something like YouTube idle. Yes. As for the renderer, I will choose compatibility because I want it to be web compatible at the moment. We will do that. And we will create and edit this. I will leave the version control to Git. In my case, I'm choosing to use version control for this project. It's totally up to you to see if you want to use it or not. It's completely optional, but just very highly recommended. If you don't know what version control is, there's a video I made about this very long time ago. You can still go watch it. It's definitely gonna fit. But yeah, before we start creating the scene, we can go in project settings and more specifically turn on the advanced settings and search for debug. Here we will be able to access gdscript warnings. I usually like to enable a few warnings in there to take care of the static typing. Static typing is something that will help you have a cleaner code, a more structured code, and to avoid mistakes. So here we have some warnings which by default are on ignore value, but I want the untyped declaration to be set to warning, the infer declaration to warning, and let's have unsafe property and unsafe method access. Unsafe cast is going to be left ignore and call argument as well. Okay, so this way we will have some messages from the editor telling us if we do make mistakes in the code. At the moment, we will not bother with any other setting. We will just create that first scene because everything we will do now can apply to pretty much any setting you will be working with on your project. In order to create a scene, we have a choice between 2D, 3D, or user interface, or actually an entirely different node if we do know exactly what node we want. But here we just want a user interface node. The editor will kindly create this little control node here. So control nodes are the default nodes for user interface thing, which are good. Pretty much all the user interface nodes inherit from this control node and they will share the same properties. Let's rename this first scene and let's actually save it. So here by creating a scenes folder, and within that scene folder have a first scene folder where we will save the first scene file. Okay. That's a lot of folder and scene words. So just so you know, you can set some colors in this editor here to improve the visibility a little bit. So I said I wanted to start by creating a resource that the player will be able to gather and spend later on, etc., etc. If we want to be able to create a resource, this is something that will exist within the script. So if you don't like programming, this is where it starts actually getting annoying for you, but yes, fun for me. So we will create a script. By default, I like to have no templates and just leave the name. I just leave the name like this. Okay. So we have the bare minimum of what a script is. Extend control. So as I said in the tutorial videos, this is a new class which we are creating, and I'm not planning to leave it anonymous. So here I will name it first scene at the moment. And I will start by creating a variable, which is going to be the resource that we will be working with in this scene. So here we will have the variable idleins integer equals 0. Okay, so what does it mean? We use the var keyword to declare that we are creating a variable, and then we create the name of that variable. Then we use a semicolon to declare the type of that variable. So you create a box, and you say in that box it will contain integers, and then you say equals 0, which is in that box that contains integers, I will set 0. Here I have added a few comments which I will add when I'm not too lazy not to do it and when I think about it, to actually help you keep track of what's going on and to help beginners to understand better what's happening. I've been told that those are useful, so here they are. The second use of these the comments with two sharp signs is that if you go in the documentation of this first scene by just searching for first scene, you will see that it automatically creates a wiki page about this class. So if you do want to keep maintaining those documentation pages by adding descriptions and what does the parameters do, etc., this is how you do it. So here we do have this variable that we will use. Now we actually need a way for the player to visualize that variable. This is why I will create a label node, which will be used to display on the screen the amount of idleins the player owns. So in the inspector, we are able to change a few properties for this label. So we can go in its control properties and find the layout to change the position. But it's a very inefficient way to position user interface objects. What we usually use instead are the anchors. By default, you can see that the layout mode is in position, but it can be changed to anchors. So I will just leave it in position right now. In the editor, you have this quick access here with this icon to allow you to choose an anchor preset. So for example, let's choose the center top. And there you go. You can see that here the layout mode was switched to anchors and that the anchor preset was changed to center top. This way it will help you to position items without having to care about the actual position of X and Y on the axis. Let's have a default value here which says that this label will display the amount of idleins the player owns. This here is the way I usually like to say that this value is initialized in the inspector and is meant to be controlled by the script. So if in the game I do see this value somewhere, like written like this, I do know that something went wrong and that something must be controlled by the script, and it is not. So I will quickly show you how to change the size of this label. So this is not going to be about the entire label settings things, but instead Godot has a quick way to change the size of label if you go in the theme category here and use this theme variation to have different header types. So here we choose header large and we have bigger text. So we can run this scene at the right top corner to say that we do correctly have this label displayed on our screen. However, we do want the script to be able to control the value displayed by this label, the value being a string of characters here. So let's go back to our script. Right now, the script is attached to the first scene node. So what it means is that this class contains the properties and the methods of the first scene control node. But the label is an entire different object. And technically, by default, due to scoping, it is not possible for the first scene to access the variables of the label here. So if I just say that text is equal to something, well, it won't do anything because the text doesn't exist in the context of this first scene. So in a way, we need to be able to have a way to reach this object in particular in order to change its variables, properties, or use its methods. In order to achieve this, getting access to this object, we will use some specific instructions, and more specifically, we will use methods from the node object, here, which all nodes are inheriting from. There are methods in there which are very useful to communicate between nodes. So first we need to grab the instruction flow to be able to add our own instructions, which we do by adding lines in the ready function. Okay, now that we are in the instruction flow, we need to go grab this label object here. Here exactly what we do want to use is the get node. We want to get the node that is existing at a specific path. The path being, well, the path in the scene tree, the node tree. So we'll see different ways to do that. So here we can say that we want to get node and we have suggested path which are label. If I remove that and just change the scene tree to show you and add a control node and put the label in there, you will see that the exact same line will result in the new path being control and then label. Because basically we're going downward like this. But we actually just want the label to be right there and remove that control node. So we want to get the node label, and then we have a reference to that node, which is allowing us to modify its variables and access its properties. So what do we do with that reference? We can either do something right away with it and use it and discard it by saying that, for example, we want to change its text properties to something, or we can store it in a variable, which is going to be, for example, a variable label like this, where we will store a reference to a label. Here, this label. In our situation, at the moment, we will just access its text property. But as you can see, as I type text, it doesn't seem to be reacting properly. The reason for this is because the editor doesn't know what type of object is going to result from this instruction here. According to the documentation, the only thing the program knows is that it will get us a node. It doesn't know that it's a label. So what we can do is specify ourselves that this node here, it is a label. It allows us to then access its properties and methods as if it is a label, which is exactly what we're doing. So we're accessing the text And we want to say that the idleans are this value. Right now I'm using string formatting. Okay, so I'm not gonna expand a lot on how this works. If you want to see more about this, you can go in the string documentation, which will lead you to this website here, which is the Godot documentation about how to format strings. The only thing I will tell you is that when you have a variable, specifically a number, that you do want to add in a string of character, you will very often use the %s placeholder to then use the % key character with the actual variable you want to put in. You will use that a lot. So here is our for line, which is quite a big line. So there are different ways to type this, especially with the $sign, which is something I will use later in the series. But at the moment, I really want you to understand that here we are using the getNode method from the node first seen in order to reach the label node somewhere in the tree. This is very important. We can now try to run our scene and see if the value is correctly edited by the script, which is happening here. We can check a little bit more by actually changing the value here and see that we correctly have a new value. Okay, so now that we have a way to display the amount of idleans owned by the player, we can think about a way to actually allow the player to create more idleans so that the value increases. In order to achieve this, I will create a button. The button will act as a way for the player to create idleans by simply clicking on it. So it's the very basic concept of a clicker game. You click on a button to generate resources. Let's position our button by using anchors and have it at the center of the screen. And for the size, in the layout, I will actually use to have a custom minimum size for it. So when you have a minimum size, what it means basically is that the editor will always try to make sure that it takes that space at the minimum. But if for some reasons, like anchors, for example, if you use this anchor, it will stretch it. So you don't have to know exactly how big it is. All you have to know is that the minimum size for it is 320 wide. And yeah, that's all it is. So anyway, the next thing I want to change is the text of the button. So here we will have grab idleans. So now that we have this button, we have to think about how we can grab the interaction. So as you may have guessed, buttons are user interface tools which are meant for the player to click on them so that something happens when you press the button. How exactly do we work with that? At the moment here, we have pretty much used the code in a proactive way, in the sense that we do things no matter what the player does. However, here we want to react to the player clicking on the button. So Godot has a very specific way to react to things happening within the game or the program. And this is signals. So basically, when the player clicks on the button like this, the button emits a signal. By default, the signal isn't caught by anything. It's just a signal in the air that nobody cares about. So what we're going to do is we will actually grab this signal in order to do something when this signal is emitted. If we go in the documentation of the button, we can actually go look at the base button object, which is a primary type for all the buttons in the user interface in Godot. And here you will see that we have the properties, the methods, and the signals. This is how we know when some signals are emitted. So here the press signal is emitted when the button is toggled or pressed. Okay, this is the signal we want to grab. Before we actually grab the signal, what I will do is create a function that will be on button pressed. So it doesn't matter how you name it. Here I am creating the landing point, because what we will be doing is create a connection or a bridge between the button and this landing point that I create here, so that when the signal is emitted, it triggers the landing point. So on button pressed, at the moment, we will just do something like idleins plus equal 1. We'll just increase the value of idleins. Now that we have this landing point, I need to create a bridge. In order to create a bridge, just like we used the label before, we need to access this button here. So in order to access the button, we use the getNode method. Then we go fetch the button. We specify it is a button, and we reach the pressed signal. So the pressed signals are a little bit weird in this way, but basically we reach the signal, and then we use the method connect. We use the method connect to say that this signal we have used, or we are in, we want to connect it to this function. And here it's a little bit special, because we need to reference that function. And we do that by just typing the name and removing the parentheses after it. When there are parentheses after the name of the function, it means that we are summoning or invoking that function. When we remove the parentheses and just leave the name, it is pointing to that function, if that makes sense. So here we just connected a bridge between the button and this thing here. However, if we start the game and click on the button, it does nothing. It does nothing because we are not updating the label. So here I'm just going to copy this line and paste it after we have updated the value here. And if we do properly click on the button, then it will increase the amount of idleins we do have. So I could leave you with that here. However, I usually like to have a little bit more of structure and organization in my code, because I'm gonna be honest with you, this is a very unclean code. It is the simplest way to do that, but on the long run, you do want your code to be clear, clean, and maintainable. The first thing we can notice here is that this line of code exists twice. And it is important because let's say that this label here I rename idlein label. If I run the game, I have an error. Okay. So I do need to change the path to idlein label. And I actually do need to change it twice because this line is duplicated. So instead of having those two lines separated and having to maintain those two lines, I will gather those in one particular method. So here I will create the update label method. And what I will do is grab that line, throw it in this new method, okay, and now I just have to call this method like this, so that if I do need to change this line here, I only have to do it once and it will modify the behavior for the ready method and the on button pressed. The second thing that we can do is actually create another method for what is in on button pressed. So this might be a little bit nebulous for some people why I bother to do that. In my opinion, and not just my opinion, but many people actually, it is very important that what is in the name of a function is exactly what happens. So here, the function onButtonPressed, what this function does is that it triggers a reaction when the button is being pressed. But the idlean being created is an entirely different problem. It is a job that another function could be doing. So here, for example, I have create idleans, and I will just have this idlean and update label in there. Okay, and here I will have create idleans. I'm going to show you why, okay? Because let's say that at some point we do want to change the way idleans are being created. For example, we want to create 5 idleans instead of 1. I do have to change this value here, okay, to 5. However, here it is in a function which is named create idleans, okay? But before it was in a function being named onButtonPressed. Do you see what I'm trying to point here? If I just open this script, at the moment it's a very simple script, okay? So there's not much problems. But if I open the script and want to go change the way idleans are being created, it actually makes sense that it is located in a function named createIdleans and not in a function named onButtonPressed. I just want you to look at this description here. This is the amount of properties and methods you have within the object node. So I want you to think about a script with that many methods in there and go try to find idleans being created when they are actually in a function named onButtonPressed. You get my point? So, okay, that was a long explanation for a very simple point, but I really want to make this clear. Clean code is important, and if you want your program to be maintainable, you have to take the time to make sure that it makes sense and it is readable. So now it is actually possible to run the game, click on the button, and generate idleans 5 by 5. And you can actually even press the Enter key. This is the white border around this button. This is because the user interface in Godot works in a similar way to the web, I believe. Well, actually, the thing is that there's the ability to have focus on control object so that you can interact with the keyboard. If you want to get rid of that, you can just go on your button here, and in its properties you can find the focus properties and change the mode to none so that it doesn't focus. So if we run the game, you will see that there is no white outline around it, and we can't use the Enter key anymore. So anyway, that's pretty much all we will be doing right now. We have created a scene with a little bit of logic in there. We have data, we have player interaction, and it all functions in a closed circuit. Does that make sense? Anyway, I hope you did enjoy this video, that it was helpful, and I will see you in a next episode.